I think we're good to go. Welcome, everybody. This is Fractionation 101. It's the second in the series for the, it started with Plant Protein 101, Fractionation, then we have today's Fractionation 101, and then we'll have Financing 101 next week. So this three-part series is really a great introduction into the world of plant protein. And we're excited to have you here. We have some great representation from Plant Protein Alliance of Alberta leadership, including the CEO, Dan. So if you have any questions about plant protein, he'll be available during the breakout sessions for you to ask any questions. Today, we're going to start with a short introduction, and then our presenters will speak for about 30 minutes, followed by a 10-minute question and answer, some closing notes for about 5 minutes, and then we'll have a breakout room where you can do some more discussion and networking with the presenters. And we'll close out from that breakout room today. So that's a great opportunity for you to meet everyone else in the plant protein ecosystem here in Alberta. And of course, we have people joining from all over the world, which is excellent. So the moderators today are Chris Glass, who is a marketing specialist with Plant Protein Alliance. He started this summer, as well as myself, Shannon Snaden. I'm a marketing specialist, and I started back in January. I see we also have Barb Wilkinson is here, and a special new addition to our comms team is Donna, who you will also see in the breakout rooms. Our presenters today are Trevor Pizzi, who is the president and principal consultant of Ansara's Processing Solutions, as well as Chance Barkley, who is an Alberta sales representative with CanSeed Equipment. So thank you very much to our presenters for taking the time to come and speak with us today. I'll do a quick introduction on who the Plant Protein Alliance is, as we have a lot of new faces here today. So the Plant Protein Alliance works on connecting people across the ecosystem. We're working to help Canada become a leader in plant-based processing. A lot of the plant proteins that are grown here in Canada are actually shipped outside of Canada for processing and then imported back here. So we see a great opportunity to do a lot of that processing here in Canada, diversify the economy, create some jobs for Canadians, and make some really great products because we grow great food. We may as well process it here as well. So that really leads to our mission. We're facilitating the development of a diverse, profitable, and sustainable plant protein and plant ingredient processing industry. And we can see that there's a good opportunity for highly functioning value chains, state-of-the-art infrastructure, commercialized market-driven products, and as I said, being a key economic driver in the Alberta economy. The Plant Protein Alliance usually holds in-person events. For example, in 2019, we had 13 different events and we had a reach of 2,500 different attendees. And people find it's often a great way to meet others in the industry and help move their business forward. We also have 2 different monthly newsletters that I recommend signing up for. We cover things like industry stories, member highlights, and industry events. There's lots of very interesting stories that you'll read. For example, when Co-op was focusing on local foods and really having a push to bring in those local foods into their aisles, as well as people like Maynard, which you'll see on the right, who does a lot of research into how to make new recipes for companies. Really great stories, really well written. So I do recommend signing up for the newsletter. And lastly, as we are a nonprofit, we do depend on memberships to continue to put on great webinars like the one that you'll have the chance to see today. So if you're interested in becoming a member, you can register over at ppaa.ca. And we have a promotion right now. You'll receive an extra 3 months with the purchase of your annual membership. And now onto the feature presentation. Trevor, if you'd like to share your screen.
Okay. So good morning, and yeah, thanks for the opportunity to talk to you a little bit about the technologies and equipment is what we're mostly going to focus on today. And so I wanted to start with just talking a little bit about, what is fractionation, and you may have, some of you that were on last week might have had a little bit of discussion about this already. But basically the process of fractionation is taking and dividing or separating up into parts. So just breaking things up. And in grain processing terms, that would generally mean that we're separating the grain or seed into several constituents, mostly protein, starch, fiber, and oil. And so fractionation is a way of adding value to the commodity by extracting these higher value components from that whole commodity that we're starting with. And separation technologies utilize physical, chemical, or biological processes to differentiate between those parts. And so there has to be something different about two parts, obviously, in order to be able to separate them. So I wanted to start by talking just a little bit about what makes up seeds and how they're composed, so that we can understand then what's necessary to take them apart and get these components that we're interested in. This slide just shows a number of different Western Canadian commodities that end up being processed through fractionation in one way or another. I think everybody today thinks of fractionation perhaps in terms of this protein extraction, but even things like wheat flour milling, for example, is a fractionation process to some extent. And canola oil crushing is a fractionation process where we're extracting the oil. So you can see that most of these commodities here, there's a lot of big green bar there. That's the starch component. And canola obviously doesn't have hardly any starch in it, but it has a lot of oil. So there's, as I mentioned, there's kind of four big pieces. There's also some sugars and other components in there, but we're primarily talking about these four big components. So common fractionation technologies rely on differences in things like size, density, solubility and electrical charge, and digestibility, all these different characteristics of those components in order to separate them. And in general terms, when we're talking about wet fractionation versus dry, like there's two primary ways that we can think about fractionation. And wet fractionation is involving usually aqueous, usually water-based separation. And when we're doing that, we're making the separation down at the molecular level. So the size of that is called like an angstrom, which is just a very, very, very tiny, like 1/10 billionth of a meter. Whereas dry fractionation is typically happening at a much larger scale. It's on the level of essentially the cellular level of the plant. So you're taking those individual cells and just breaking them up a little bit. I want to talk for a minute about what those main components are that I mentioned on that previous slide, and some of the key characteristics that help us then use technologies to get them apart. So proteins, which you heard a lot about if you were on the webinar last week, are basically built from amino acids, and they're relatively large molecules. There's a whole bunch of amino acids that are strung together in a chain, and then that chain ends up getting folded and pleated, and you end up with this sort of clumpy protein particle. It has an electric, or it has a positive or negative charge, and will move in an electric field. So that is one way that we can sometimes separate them. And another characteristic of proteins is that they have what's referred to as an isoelectric point. So you can put proteins into a solution, into a solvent like water, and at a certain point they will be soluble. And at a certain other pH level, they will not be soluble and they will precipitate out. And again, that's another technology that can be used then to separate them. Carbohydrates, which are made up of simple sugar molecules just stuck together in a different order, include sugars, starches, and fiber. They're big classes of carbohydrates. And so that includes all three of those were mentioned in that breakout slide for the different commodities. A couple of key differences among some of these are that starches generally can be dissolved in water, and cellulose, which is a fiber though, does not. So we can start to separate these out again because of how soluble they are. And then fats are built from fatty acids. And on the left-hand side there, you can see what's referred to as a triglyceride, so 3 fatty acid molecules joined together. A couple of key characteristics there are that they are less dense than water, so they'll float. The photo on the right is something that you might see in your kitchen where you have, say, chicken stock, and if you let it sit, that fat will float to the top, and then the solution below that, which has a lot of proteins in it, which is causing it to, as it cools off, it becomes like a gel. So it's temperature dependent, and it's also density dependent, allowing us to make separations there. Fats are soluble in organic solvents like hexane. So if you go to a canola crush plant, that's one of the methods that's used to separate the oil out of the canola from the meal, which is made up of protein and fiber mostly. They can put that oil into solution in the hexane and then remove that and then separate the hexane from the oil. Okay, let's take a look at how seeds are basically composed and whether they are oil seeds like canola or soy, or whether they are starchy seeds like wheat or barley or legumes. They generally have similar characteristics. There's a seed coat around the outside, which is mostly made up of carbohydrates, fiber. And then in the inside, there's a whole bunch of cells in there, which are storing energy molecules, starches, fats, and proteins. And so when we're talking about dry fractionation, basically we're taking these seeds and we're breaking them up to the point that we can start to differentiate these starch and oil and protein particles from one another in still their relatively large clumps, if you want to call them that. Whereas in the wet fractionation, we're breaking this all the way down to the molecules. So I've got a couple of photos here to show you so that you can maybe envision this a little bit better. These are all pictures of pulses. So we've got beans and chickpeas and lentils here. Anywhere you see an S, this round little particle here, that's a starch granule. And in between all of the starch granules is a whole lot of a protein matrix. And the protein particles are much, much smaller than the starch. So you can see there's a bar here for 30 microns. So most of these starch particles are sort of 10 to 20 microns, whereas the protein is down in that 2 micron range generally. You can also see on this top left photo that the cell wall is outside of that protein and starch matrix, and that cell wall is mostly made up of fiber. So when we're dry fractionating, we're basically trying to break this up to the point that we can differentiate on the basis of size these protein particles from these starch granules. If we look at an oil seed, it's very similar. It's got this cell wall around the outside, which is again made of fiber. And then inside we have protein bodies. and oil bodies, and they're very similar in size in the oil seeds, again, sort of in this 2 micron range. So I've mentioned that we have wet fractionation and dry fractionation. Here's a high-level process flow, and if you have starch-rich legumes, so lentils and peas and things like that that don't have any oil in them, generally in a wet process, we would go through the left-hand side here. We grind it down, put it into water, and then we use hydrocyclones, and I'll show you a photo of those. Basically, we're separating there with very high rotational speed. We create a lot of centrifugal force and just take the larger particles out from the smaller particles. And then on the basis of some of those things I had mentioned about proteins that we can put them into solution depending on the pH. We can go through that process of solubilizing them and then precipitating them, and then ultimately we dry them to get the protein isolate that we're interested in. On the oil-rich legumes, you have to take the oil out first because the oil interferes with a lot of the rest of that separation process, but then the last part of it is similar. And as I mentioned on the dry fractionation, we're basically taking and milling it down, and then a common approach is to use air classification, which allows us to separate those starch granules from the protein bodies on the basis of how large they are. So some of the key aspects that are different between wet fractionation and dry, I mentioned that the particle size we're talking about is sort of at the molecular level in wet fractionation and at that micron level close to the cell size for dry. With regard to the purity of the fractions, by doing the wet fractionation, you can produce what are referred to as isolates, so very high concentration, like 85% or more pure protein. In the dry fractionation, you only are able to concentrate it up to about order of magnitude 50% protein. We obviously use a lot more water in wet fractionation, and we use a lot more energy because we then have to dry it down once the extraction is completed. There's also a fair bit of chemical use is common, not always, but it's common in wet fractionation because we're trying to manage that pH by adding acids or bases. Some protein extraction also requires high salt content, so there may be a lot of chemicals that are added in the wet fractionation process, and that doesn't happen in the dry. You maybe are familiar with protein denaturation. One of the things that, so if you're gonna cook an egg, you take and you break the egg and you put it onto a hot surface, and the white of the egg solidifies, and you can see that it changes, right? So what's happening there is those proteins are being changed by the heat. And heat or chemical reactions can cause those proteins that we mentioned are all folded up to change in structure. So that's something that can happen more commonly in wet fractionation. And we need to be careful about that because it might mean that the proteins that you're getting out are no longer as functional as you would want. And then the last difference between wet and dry fractionation is really the kind of the cost between the two of them. Most wet fractionation plants are, tens to hundreds of millions of dollars. You've probably seen media coverage about the Roquette plant in Portage Prairie. That P plant is about $600 million now. Dry fractionation is typically in the order of magnitude, so 10% of the cost for the same capacity. Okay, and then just before I turn this over to Chance to talk about some of the dry fractionation technologies, I'll just show you a few examples of the equipment and technologies that would apply on the wet side. In the front end of the plant, so preparing the material before it goes into fractionation, that process is very similar between wet and dry. Chance will talk about those. And then we kind of start on the wet side with grinding and slurry dispersion. So you've got equipment such as this blue grinder here. We have things like centrifugal sieves up on the top right here, where you're pumping a slurry in there. And because those fibers don't break up very easily, they stay larger, and the proteins and starches will go through the sieve and the fiber can be removed. So that's one way of separating things. Decanter centrifuges and disc stack centrifuges are somewhat similar technologies where they're using very high rotational speeds in order to separate slurries and get dry matter out of wet, or to separate high and low density slurries. You've probably heard of things like ultrafiltration. That's the use of membranes. So you've got these very large pieces of equipment here where you're basically passing water, and the very small molecules will go through a membrane. So it's sort of like a sieve, but it's much, much smaller. And then the large particles will stay on the other side of the membrane. So you're creating a lot of high pressure and uses a lot of horsepower to do that. And then ultimately, as I mentioned, when we get to the end of the separation, we need to dry the material. So common drying technologies for this would include things like spray dryers that you see over here on the right. I think this was actually from a dairy processing facility. And on the left here, we have ring dryers. You can see the scale of these. Like, these are multi-stories tall for a big facility. There's obviously small scale equivalents that are used in pilot plants and lower capacity facilities. But a lot of the large scale facilities, like that Roquette facility under construction in Manitoba right now, the scale of these dryers is quite enormous and obviously very expensive. So Chance, I'll turn this over to you now, and you can go ahead and talk about the dry side.
Everyone hear me?
Yeah.
Yep. Here.
Yes, we can hear you.
Okay, thank you, Trevor. So I will go through a really brief, broad overview of some of equipment necessary in the dry fractionation side. Something I want to cover off on really quickly is the potential need on the front end for pre-cleaning. This is a relatively more basic part of the operation, but an important one. I'll talk about it at the end of the presentation a little bit. It may be worthwhile for a owner to use a third-party resource for this. However, I do want to touch on it really briefly. So your raw material coming in, if you do have needs for pre-cleaning, you want to use some type of rough cleaning, whether that be a drum cleaner or air aspiration. Your primary purposes here are to reduce your chaff odds in the material. And your secondary purpose is to remove foreign seed from your primary seed that you're trying to put through your process. Other than that, there's not much else to it. So we'll move on to the next one. Further pre-cleaning here, air screen machines, rotary drum sieves, depending on the application. This is typically more used in fine cleaning and grading. Your primary purpose here is to do a closer separation of like from similar. And what I mean by like from similar is anyone who is a front-end agricultural producer knows you always get some type of cross-contamination of your fields, even if you're a pedigreed seed grower. So this could be cereals in your peas, or vice versa, or foreign cereals in your cereals, or foreign pulses in your pulses. So what you're trying to do here is just reduce your foreign material. So let's say we're processing field peas in our dry fractionation process, and we have some wild oats and or barley that's 0.05 or 0.5%. To mechanical machinery, those products can look really similar. To our naked eye as a human, they look very different. And that's what I mean by like from similar. Size and length of a pea compared to an oat can actually be quite similar, but it's a very different product. Your secondary purpose here with your fine cleaning and grading is to separate like from like. So depending on if it is a multi-product process, meaning you're exporting whole grains or subcomponents that also go into the fractionation process, you may want to separate like from like. So this would be, if we're doing field peas, this would be diseased peas, cracked, broken, rotten ones that maybe are not the most suitable for the fractionation process. Yeah, so it's separating your bad peas from your good peas. If it's a full fractionation process and you're not using a front end to market whole peas as part of your business model, then at this stage, you're likely not taking very much out of your peas from your primary pea product. Final step of your pre-cleaning, more specialized equipment like your gravity tables, your destoners, your color sorters, and your primary purpose here is to removing any remaining foreign material. So going into the fractionation process, you have some more expensive equipment that I'll talk about in a minute. You don't want any stones, you don't want any foreign material going into it. Number one, from a purity perspective, but also number two, from an equipment integrity perspective. That can be very damaging on your process, and downtime in your process can be very costly as well. So that's it for the early part of the pre-cleaning side of it. What I'm going to go into right now is your basic dry fractionation process. This is a process flow from a client that we're working with currently. They are pursuing a multi-product strategy. So this is not only a dry fractionation process. This is a dry fractionation as a subcomponent process, but moving into a wet process. So what I'm going to talk about a little bit is the front end of the process, which is on the left-hand side, which is your dehulling and your hull removal. And then the middle part of the process is a little bit unique to this one client. So I'm going to touch on it very briefly, and then I'll move into the more standardized approach of a dry fractionation. So your first step in your fractionation process is your dehulling. Relatively inexpensive, simple technologies. However, the proper technology should be used here. The more appropriate technology would be the one on the left, which would be a emery stone mill type application. There are some people using impact mills, which would be the one on the right. And your primary purpose here is to remove that outer cell wall to give access to the seed and basically just make your fractionation process a little bit more efficient. Relatively inexpensive again, simple to integrate into your process. After you've removed that hull, you then you have good product, you have cracks and brokens, and you have hulls. You need to separate these two products. So your two separation technologies that are easiest to use would be like a cascading or a multi-pass style aspirator, which is what you see on the left. Or in certain cases, depending on plant layout, you could go to more of a combined model, which is on the right, which is a vibrating screen deck conveyor. This has the benefit of conveying material, but also screening off some of your lighter hulls. The more standard approach would definitely be the one on the left. Again, relatively inexpensive, but depending on the tonnage that you're trying to put through your mill and or your layout, each of them have their own applications. On a per unit cost, definitely the right-hand vibrating conveyor is much more expensive than the two options on the left. So what we see most often would be that cascade or multi-pass aspirator that you see there. So that's the front end of the process there, which you see again on that left side of the process flow. What we're going to do now is move into the actual fractionation side of the process, which is the middle portion that you see in the middle of the screen with your scaling, your grinding, and your fractionation. So the first part of this process is not 100% necessary for output, but as Trevor spoke about earlier in terms of the level of investment that you're making, whether it be for dry or wet fractionation, we're talking many, many tens of millions of dollars for any significant tonnage. At that level of production and level of capital cost input, you're really, really trying to manage on fractions of percentage points what your input and output are. One of the ways that you can do that is inline scaling, either coming into process, in process, or after process. Again, this is not 100% necessary, but relative to the cost of an entire project, this is really a management tool that makes it easier for you to measure that shrink that you're incurring in your process, and just allows you to eke out those little small gains that you want over time that are incremental and really necessary to drive margin in your business.
All right.
So first part here is your kind of unique scenario that I mentioned previously. We have a client that is looking at a multi-stage process, which is a combination of dry fractionation and wet fractionation. In this case, they want to use a dry fractionation subcomponent that moves into a wet fractionation process in order to be able to market it if they want or so choose separately. They're also pursuing a whole goods model in terms of dehulling and moving export pulp as well. So in this case, as I had on the slide there, it is most suitable for a semi-wet process. Anyone who's familiar with flour milling or other industries, on the left there you see a multi-impact hammer mill. This is a fine grinding hammer mill. So it gets you right to the precipice of the micron size that Trevor is talking about for dry fractionation, but not fully into it. So this is more of an efficiency product in a wet fractionation process as a subcomponent. So this is getting your micron size down using relatively efficient and inexpensive technology. And as discussed earlier, this client is trying to use this as a subcomponent that they can market separately as basically a whole ground peat. Trevor also discussed earlier on the wet process side, centrifugal sifters using slurry mixes. This is essentially a dry version of this, super common in flour mills as well. It's a rotating sifter that's using high centrifugal force to push out material. In this case, all you're really removing is the bran, and you're reducing pretty significantly the particle size in order to move into realistically a wet process. But as discussed, kind of an interesting option for some people that are trying to pursue this stage. Onto the more common approach here, we would be looking in a true dry process at a fine grinding mill, which you see on the left, which is using air swept technologies, really reducing that micron size to what Trevor alluded before to break apart the protein and the starches. And then you're moving on to what you see on the right and passing it through an air classifier. What we're trying to do here is use the relative density and weight of this material under an air column to push that material in one direction further than the next. So your protein versus your starch, it's going to fly further through the air. Anybody who's been to ag trade shows in the last couple of years, there are some kind of on-farm, not nearly as efficient or capable of making fractionation cuts to this level type machines from someone like Lemon that would sell this type of material. But the basic technology is exactly the same. You're using an air column, you're floating this fine grinded material through that air column, and certain particles will fly farther than another. And that's how you're sorting your classes of products into their different classes, your protein, your starch, and finally, we've talked about these mills, we've talked about air classifiers, we've talked about aspirators, we've talked about pre-cleaners. The common concept between all of these is they require air. Your air equipment in a plant, there's two primary purposes. In our case, from a process perspective for dry fractionation, we're really focusing on lift, whether we're lifting those hulls from the full material, or whether we're providing lift in the air classifier mill and or air classifier. We need air to do that. This air equipment provides lift. Your secondary purpose, and one that we're running into more and more in Western Canada, is primarily, especially with industrial facilities, but in the small, medium size of the market as well, regulators are asking for more and more environmental controls of even farm accessory type buildings. And your secondary purpose here is to have environmental controls and safety for your operators that are working in the mill. And last but not least, I want to just have a really brief overview. I touched on it at the beginning when I started there. There are strategies that you can take to break up this process in order to reduce capital, reduce amount of real estate that you need to produce a mill, whether it is dry or wet fractionation, or just focus on your process that you're good at and have someone else that you partner with that helps you with another part of it. So you have to ask yourself, are you going to handle the entire process, or will you partner with third-party organizations? In our experience, it's more than likely that if you do partner with a third-party organization, it will be for that preconditioning stage. There's a number of third-party cleaners that are willing to do this type of work in the marketplace, and it's a relatively inexpensive endeavor. Your one exception of that in a more advanced stage would be a co-packing agreement. So you would create the primary product, which would be a dry fractionated product, possibly put it in mini bulk bags or bulk truck it to a third party location, and then have them put that into a different size bagging type operation. This is typically a shorter term strategy. And based on the amount of money that you're spending, this is typically something in the short, medium term that's very rapidly brought in-house. What you also have to ask yourself is, what's your best bang for buck for your organization? These processes, whether it's wet or dry, they're quite capital intensive. And you have to ask yourself, what is the quality of product I'm looking to produce? And then work back from that level and decide how much capital you're willing to commit. On the flip side, if you're partnering with third-party organizations and reducing your personal capital input, you're also then relying on others to help you with the production of essentially what's a high-value, a reputation-based product. And if you have any reputational claims because of your third-party resources, that's a potential risk to your business, especially being a high-margin product. The last but not least, and I would say really important, is a lot of these organizations we're finding are smaller when they start, really small teams. They're scaling up quite rapidly. And they have to ask themselves, what is your skill set as an organization, particularly from not just the planning side, but the processing side. This is a relatively new industry to Western Canada, as well as worldwide. It does exist in other areas, but it's pretty hyper regional, pretty local. People who have direct experience in dry fractionation are going to be few and far between. So it's going to be quite costly to import your skilled workers. And more than likely what you're going to have to do in Western Canada / North America is find workers from other industries, i.e. as Trevor alluded to, canola crush, flour milling, who have experience in ag-based industrial processing and can transfer some of those skills. They may not understand the process to its T, but they understand as operators, as process engineers, how to manipulate the process, and then just retrain them specifically in your process. That being said, I think we're going to open this up back to Shannon and potentially to some questions.
Wonderful. Thank you very much for the excellent presentations. I'll just start screen sharing here. So now we'll open it up to questions. So if you can type your question into the chat, then Chris will read out the questions, and then Chance and Trevor, you can decide between each of you who would like to answer it.
Perfect. And we have our first question from Leanne Murphy. What are the trade-offs in multi-crop, multi-purpose versus single crop, single purpose facilities that should be considered?
Trevor, do you want to touch on that? And I'll maybe touch on the cost side a little bit.
So I would say that so many of these commodities are very unique in how they need to be fractionated. More so on the wet side. The dry fractionation is a little more applicable across multiple commodities, but in general terms, on the wet fractionation side, each of those extractions is very unique. The proteins that are in a commodity will have different properties versus a different commodity. And so you're generally going to be able to do something across multiple commodities only with dry fractionation.
Okay, our next question. For wet and dry fractionation, does the equipment need to be recalibrated?
In terms of the person that's asking that question, do we mean in a mono process there or in relation to the last question for multi?
No, I think my question is if with regards to the product, if you're fractionating a different product and trying to use the same equipment, and then does that equipment need to be recalibrated depending on the product?
Yeah, 100%. I mean, even in the same product, if you're always running, say, peas, you're going to have to recalibrate equipment. I mean, flour mills operators constantly walk around and tweak all of the equipment depending on the cuts that they're seeing, right? A given year will produce a product with more protein or more starch because of a drought year or a wet year. As Trevor alluded to in the last question, if you have a situation where you're trying to run multi-products in a fractionation process, it can be quite difficult both on the dry and the wet side from a calibration perspective because these products have completely different characteristics.
Okay. Does the taste profile change between the two types of fractionation?
I would say yes, because the two, as I mentioned, are producing a different quality of product. I mean, they're both high quality. They have very specific applications that you can use them in. But in general terms, your isolates that are coming out of the wet fractionation are more pure just protein, whereas out of a dry fractionation, you have a lot of other material in there, and all of those components have their own taste profile that they contribute to the overall organoleptic properties. So you are definitely going to see some differences in the taste characteristics. And with the wet fractionation, you know, some material like stays in and goes out with the effluent, with the wastewater from the plant. So there are components that are lost there as well, which also have a taste component.
Okay, thank you. Mark Olson is wondering about the speaker's thoughts about working back from the ingredient company or end user needs. Some get the impression you grind it up and separate it and the customer will knock down your doors to buy. What about working from the end user back?
I think that's a really important point because, as I mentioned, that the protein quality, the starch quality can be affected by your process, and the suitability of each of those fractions for any given application will depend on what your process is. So, you know, you can modify your process to get different properties or functional characteristics of the ingredients that you're manufacturing. And I absolutely agree that, you know, there's going to be certain requirements that certain customers have.
The one caveat to that we would say is because it's such a small industry and there's limited producers currently, the ability of you to produce sample material and send it to those end users may be very limited because you're going to effectively be asking for material from your direct competitors.
Okay, thank you. Do pea and faba crops look for development for increasing protein content for dry fractionation? Sorry, how do pea and faba crops look for development in increasing protein content for dry fractionation?
Well, faba is one of the highest protein content pulses out there. And there's certainly, I would say, increasing attention on faba. Pea has got a lot of attention because of the volume that's growing in Canada, and there's some very positive attributes about the protein characteristics. Wish David was here from last week. He could probably answer some of these questions better than I can. But there is ongoing effort, not only in pea and faba, but on the canola side as well, with genetics and trying to breed for higher protein content and or better quality protein in the commodities.
Okay, we have a couple more questions to get through here before we go to our breakout rooms. For wet fractionation, which equipment is most used or recommended? Is there a standard equipment?
Yeah, it really depends on exactly what you're doing. I have clients that have worked diligently with PhD chemists for 5 or 6 years on optimizing, you know, a process to get one component out of a commodity. And so the equipment that you require and the operating parameters at which you run that equipment is very specific to the fraction that you're trying to extract. And I don't really think that there's a standard that you could say it would apply across the board.
The general equipment is similar, but as Trevor alludes to, it's drastically varies in that class of exactly what you need.
Okay. How many fractionation facilities do we have in Alberta? If you know.
None to either of our knowledge, I think.
Answer that.
Okay. What do the speakers suggest for a crop kind that has 6 to 8% oil, somewhere between a protein crop and an oil seed? Would that be dry fractionation or wet fractionation? What do you think?
Dry is challenging because the fat content in there tends to cause the starches and proteins to stick to the equipment. So oats would fall into that class, and I've worked with oats on air classification equipment before, and it's definitely challenging. Having said that, on the wet fractionation side, that oil content level also produces some challenges because a lot of the technologies on the wet fractionation side, like membranes, they don't like dealing with that oil in there. And so generally the wet fractionation, you would need to go through a process or a part of your process to extract that oil so that you can efficiently do the separation on the remainder.
Okay. The size of investment is very large, tens or hundreds of millions. Investing these quantities is probably found in the US or offshore. Should Alberta be more focused on offshore investors, or what is your feeling there?
I think this really depends on where the end user market is. One of the primary user markets that this protein isolates and concentrates are going into is the health food industry. And that health food industry is primarily driven by North American and European eating habits. That being said, most of probably the investment that this would come from, in my personal opinion, I don't know if you want to touch on this, Trevor, would likely be from overseas or the US, just based on the capital requirements. I think we have the capital requirements here, but there are some offtake agreements, partnership advantages to being closer to those end markets and having the capital actually come from those end user markets.
Okay, thank you. At this point right now, we've ran out of time for questions. I see that there's plenty of good ones still to ask, so I'm going to ask you to hold on to those for the breakout rooms. Shannon's going to put everybody in our breakout rooms for the next 10 minutes. So make sure you're asking those questions in there, and a little bit more of an intimate setting for everybody to talk to our guest speakers. So we will see you in the breakout rooms shortly.
Perfect. Thank you, Chris, and everyone for all the wonderful questions. Real quick, because I know that we have some participants who will not be able to stay for the breakout rooms. Our next webinar is next week, Financing 101. Please be sure to sign up as soon as possible, as that one has limited space. As well, we'll be having a mental health and agriculture webinar in January. And I'm now opening up the breakout rooms. Please go ahead and join into your room. Oh, perfect. Okay, we'll wrap it up there. We're about 10 minutes after our end time. So thank you very much, everyone, for coming. We'll be sending out an email after with some information so that you can contact our speakers if you have any other questions. As well, there will be a survey link so you can let us know how you thought it went and how we can improve in the future. And we'd really appreciate that. Please don't forget to sign up for our next webinar for Financing 101, which is happening next week, same time, same place. Okay, thank you very much.
Before you go, were the slides available for us to download? I think there was some useful information there.
They were really good slides. Yes, the presentation will be posted on YouTube in the next couple of days.
Sounds good. Thank you very much. Thank you, Shannon.
Thanks, Christopher.